Hey everybody, Mrs. Bixler here. We're going to continue our conversation about factoring, but we're going to factor trinomials that look a little different than the ones we've been working with. So I wanted to show you one, and this is one that we're super comfortable with, x squared plus 6x plus 10. We've been calling these trinomials, but they actually have a cooler name. This is something called a quadratic expression. If there's a little equal sign and it's set equal to something, we would call it a quadratic equation. But don't worry too much about that right now. So a quadratic expression, the reason why it's called that is because we've got an x squared term. So anything with an x squared term is considered a quadratic. And quadratic expressions, if we write them sort of in their general form, we write them like this: ax squared plus bx plus c. And a, b, and c just stand for the leading coefficients. So c in this case would be 10, b in this case would be 6, and then our a in this case would be 1. So we've been working with quadratic expressions and factoring quadratic expressions that have a leading coefficient of 1 for the most part. And those have been pretty straightforward, and I think we should feel pretty comfortable with those. If you don't, go watch those other videos and then come back. So now we're going to switch it up. What if we had a quadratic expression, but now my a is 2? So see how my leading coefficient now is 2? Well, we've actually seen these before because the very first question we always asked ourselves was, is there something I can take out of each term? And in fact, there is here. There's a 2 in every term. So I can factor out a 2, and then I'm left with x squared plus 6x plus 10, the exact one we had before. But now look, I've got a leading coefficient of 1. So my a is 1, my b is 6, and my c is 10. I can now factor this guy, and just the way we did before. So it's not really exciting when my leading coefficient is just something I can factor out of each term. But what if I gave you a quadratic expression that looked like this? So my a is still 2 here. My leading coefficient is 2. But can I take a 2 out of every term? The answer is no. So we're going to talk about how you factor something that looks like this. So do you see how my leading coefficient, my a, is not equal to 1? And it's not something I can just factor out. And so that's why these guys are different. So let's remind ourselves, the very first step, when we had a being equal to 1, and this is the original quadratic that we saw on the first slide, we always did this first. We drew our two little parentheses, and then we put an x here and an x here. And we knew to do that because when we FOILed this new binomial out, we knew that our first two terms, x times x, had to be x squared. It had to be that first that first term, right? So when we multiplied x times x, we knew that we had to get that first term. So when we multiply the first terms of our binomials, we always get this leading first term. So let's keep that in mind. And I'm going to go to dual page display because it's awesome. All right, so when a equals 1, here's what we do on the left. But now let's look on the right. When a doesn't equal 1, you're actually going to wind up doing the exact same first step. So I'm going to make my two little binomials here. And I know, I'm going to scooch myself over. Can I do that? Whatever. All right, so I'm going to first fill in these two binomials. But before, remember how we put an x and an x first? Well, I'm not going to do that here. I'm going to do a 2x and an x. And the reason why I do that is because when I FOIL this out, I know that 2x times x has to give me 2x squared. So that's the first step. Whenever you have an a that does not equal 1, you're always going to put in that 2x and x. Or if this was a 3x squared, it would be 3x and x. Or if it were a 5x squared, it would be 5x and x in those binomials. It gets a little tricky if your leading coefficient is not prime. So if you have something like a 4x squared here, well, you could do a 2x and a 2x in our binomial, or you could do a 4x and a 1x. Don't worry, that's not coming up. It's okay. So I want you to feel comfortable with this very first step. So I'm going to turn off my dual page display. Fab. All right. So now let's go to step 2. So right now, step 1, we've already got our 2x and our x. But now we've got to think about what's going to go in these green spots. And here's great news. I know what goes in these 2 green spots. They have to be the factors of 5 because when I FOIL this binomial out, I get my first 2 terms, 2x times x gives me 2x squared, right? Which is what we just did on the slide before. And then when I multiply my last 2 terms, when I multiply this guy times this guy, I know I have to get 5. So what goes in these 2 spots have to be factors of 5. So I've made this a little easy for us because 5 is prime. There are only 2 factors that can go in those slots, which is kind of nice. Now, if it were a 6 or a 12, or God forbid, like a 24, we'd have a lot of numbers that we could possibly put in there. But for right now, we're just going to deal with a 1 and a 5. So there's our second step. And now our third step is actually determining where those 1s and 5s go. So let's do this out. So let's say that I put in, I know that I've got a 5 and a 1 here. So I don't know, let's say that I just did a 1 here and a 5 here, just to see what happens. So I know that if I FOIL this out, my first 2 terms are going to give me 2x squared. My last 2 terms are going to give me 5. But here's what I care about, my O and my I, my OI, right? I care about the O and the I because I need my O and I to combine to get me a 7x. So let's multiply these 2 together. My outer 2 terms are going to be 2x times 1, which is 2x. And my inner 2 terms, which are 5 times x, which is 5x. Is there any way that I can combine those 2 and get a 7x? Yeah, if I add them together. So this winds up being the final answer to this factored problem. I know it seems a little tricky, but we're going to try another one together. All right, so here is a second problem. I've got a leading coefficient that is not 1, but luckily it's a prime number. So we know our first step is going to be making our 2 little binomials, and I've got a 3x and an x, because remember, if I FOIL this guy out, that 3x times x better give me 3x squared, which it does. But now this one's a little bit trickier. So now I've got a -10. I've got to figure out what goes in here. So factors of 10. Well, I've got 1 and 10, and I've got 2 and 5. So this one's a little bit more complicated than what we had before. And now we just kind of guess and check, because no matter what we put here or here, when we multiply them together, we're going to get a 10. So now what we care about is our O and our I. Oi. All right. So we care about the O and the I. So now let's just throw something in there, and I'm just going to kind of make this up. I'm going to put my 1 and my 10 here. Okay. So now let's FOIL this out. My first 2 terms, great. 3x times x is 3x squared. We know that. All right. My outer 2 terms, 3x times 10 is 30x. 1 times x is x. All right, well, is there any way that I can combine 30x and x and get a -13? Nope, no way. All right, so back to the drawing board. Let's now see, what if I did, so I did a 1 and a 10 here, right? So what if I did a 10 and a 1? So what happens there? So if I multiply these guys out, so I know my first 2 terms, 3x squared, my outer 2 terms, 3x times 1, is a 3x, and 10 times x is a 10x. Ooh, I like this. Is there a way that I can combine 3x and 10x to get a -13? Well, yeah, I subtract them. So this would just be this, except you have to be careful here, because if we were to FOIL this out, I'd get my 3x and my x, 3x squared, my outer, my inner, but my last, -10 times -1, would give me a positive 10 here. And if you look up at the original problem, it's a negative 10. So 10 and 1, unfortunately, do not work for us. So back to the drawing board. All right, let's see what else we can put in here. So let's try 2 and 5. All right, so I'm going to put in a 2 and a 5, and let's multiply these out. So 15x and 2x. Ooh, I like this. So is there any way I can get a negative 13? Well, yeah, negative 15 plus 2. So 3x times negative 5 and then a positive 2x. Let's just double check that our L works out. So 2 times negative 5. Amazing. So this is our final answer. All right, one more, and then I'm going to let you go. So try this one on your own. Pause the video. All right, we're back. So hopefully you did the first step on your own. You got your 5x and x. And then if you wrote out your little foil to help you, you know that what goes here is 5x squared. All right, you feel good about that. And then you know what goes last has to be a 6, a negative 6 technically, but don't worry too much about that yet. All right, so now we've got to find factors of 6. So we've got 1 and 6 and 2 and 3. So I don't know, let's try 2 and 3 because 1 and 6, I don't like how that feels. So let's put in 2 and 3 here. So remember, we know what our F is, we know what our L is. What's different and what matters is our O and our I. So let's multiply these out. 5x times 3, that's for our outer two terms. That gives me 15x. And 2 times x gives me 2x. Ooh, this is kind of nice. Can I combine 15x and 2x and get a 13x? Yes. 15x minus 2x. So I'm going to get a positive 15x and a negative 2x. Let's just double check. Negative 2 times 3 gives me that negative 6. And so this is your final answer. Woo! All right, go try the worksheet, and don't worry, we're going to go over all this in class. See you soon.